Okay, so as far as what's coming up, you guys have had the homework that's due up until now. I think there was one due at 12:15. And then did you guys see in the email that you're allowed to request extensions on WebAssign? It like will automatically extend that for you. So if you do forget to do an assignment, or if there's like a few that are harder and you want, like somebody was saying they wanted to ask about the trig ones afterwards, like you just request the extension, you go into the assignment, there should be a big button that says request an extension, and it will let you request the extension for up to 2 days after the original deadline. So if it was due today, you can request the extension up until Wednesday, basically at noon. And then when you request the extension, it gives you 48 hours from then to actually complete it. Anything you do after the deadline is for 80% credit. So it'll dock you a little bit, but it's for 80% credit for any of the problems you do after. So if it's just like, you know, there are 3 or 4 you couldn't figure out, that's not a big deal at all. If you miss a deadline every now and then, it's not a big deal. You don't want to be doing that all the time. But if there's a couple problems every now and then, that's completely fine. And that's kind of the idea. Any questions about that, about how that works? I think it's pretty easy. It just will automatically do it. Now, if you like join the class late or something like that, I'm going to extend the assignment without any penalty, so don't worry about that. I think I've already done that for anyone who's joined late, but if you haven't, let me know and I will be happy to do that. And then if somebody does get penalized between now and Wednesday for an assignment, I will get rid of that penalty since it's the first week when people are still adding in dropping classes. So if you've forgotten to do something, go ahead and request the extension, and then I'll remove the penalty, let's say for anything up until this Wednesday. So like the first week. Is that fair with everybody? Okay. And so same deal, like same thing. If you just forgot to do a couple problems or you couldn't figure out a couple, I'll get rid of that penalty too. You just got to tell me, say, hey Doug, I went in and it gave me 0.8, and then I'll just go adjust your score later. Sound good? All right. Any questions? You guys are all good? All right. So we're going to start talking about actually a derivative. Let me share my iPad. There's always a little delay the first time, but here it goes. Should go. Come on. There it goes. All right. Can somebody just thumbs up that we can see this, or unmute yourself? Tell me. Okay. Okay. All right. So this is notation. I think they use some in Calc 1, maybe not a whole lot. So this d dx means take the derivative of that. And so the derivative of this with respect to x is what? And so real quick, just do that problem. See if you remember how to do that. If not, we'll talk about it in just a second. But I want to see if you can do that problem. And then check the answer with me in a minute. All right, so somebody want to explain it to me? It's okay if you don't, but somebody want to unmute, just tell me what to do. You guys do. So you bring the 10 down, right? So we do 10 times 5x cubed minus 7 to the 9th. We're not done, but does everybody remember that we started that way? Because it's basically like x to the 10th. That's good. Okay, and then what do you do after that?
You multiply that by the derivative of the inside of the parentheses.
Perfect. You multiply by the derivative of the inside, and so that's going to be times 15x squared. And so then that simplifies a little bit to 150x squared times 5x cubed minus 7 to the 9th. Does that make sense to everybody? We good? Okay, and so what I want to start looking at is how to reverse this. So like if we were to do the antiderivative of 150x squared times 5x cubed minus 7 to the 9th dx, apparently, what's the answer to this? So if I said find a function whose derivative is this with respect to x, then what would that be based on what we're doing up here?
5x cubed minus 7 to the 10th.
Perfect.
All that to the 10th.
Yeah, 5x cubed minus 7 to the 10th. And then we could have plus c. But yeah, so that's all of the antiderivatives of this. I think it's not obvious looking at this that this would be the answer, but it is when this problem's sitting up here. Does that make sense to everybody? You guys clear? Okay, and so what we want to do is reverse this. And what is this that we're doing here? What's this called when we do like times the derivative of the inside? Do you remember?
Chain rule.
That's the chain rule. And so we're going to reverse the chain rule for antiderivatives. And so that's the next thing in the class. So last week, what we were doing was reviewing from Calc 1 how to reverse the basic rules of differentiation. So we talked about the power rule, the exponential rule, the log rule, 6 trig rules, and 2 inverse trig rules. So there were 11 rules that we reversed from Calc 1. We also talked about the sum and difference and constant multiple, where you could split up addition and subtraction, and you could pull constant multiples out. Those are reverses of those derivative rules. In Calc 1, you also have the chain rule. You also have the product and quotient rules. And we want to reverse all of those. We start with the chain rule, and then later we will talk about how to reverse product rule in particular, but also we'll talk a little bit about how to reverse the quotient rule. It turns out we don't need to do that, but we'll talk about why later in the course. And so we're going to reverse those. So the process that you use to reverse the chain rule, that is called U substitution. And so we're going to go through this process. A lot of you have already studied U substitution. And so I'm going to show you a way to do U sub. It may be the way you learned it, or it may be slightly different from the way you learned it. And so just so you all know ahead of time, when you take a test or a quiz and you need to show me the work, if you have a different way to show the work that is mathematically legitimate, that is okay, even if it's not the same as mine. Does that make sense? Now, it can't be like way, way off, but like if your U sub looks a little different from mine, that's okay. The way I'm going to show you, I would recommend trying to do it that way, because if you are doing it the other way that you may have learned or you may not have, if you're doing it a different way, later the harder problems I think are much harder that way. And so we'll talk about that kind of when we get to it. But if this is a little different from what you've learned before, I would recommend trying it this way, but you do not have to do that to make me happy. Does that make sense to everybody? And then if you've never learned U, yeah, okay, good. If you've never learned U sub before, completely fine. You can learn it the way that we're going to do it. All right, and so let's look at it. Like I said, you may have just learned it this way anyway. So let's look at this problem. So we're going to look at the integral of 7x to the third times 5x to the fourth minus 2 to the 9th power dx. Now, this is not the same as the problem up here. It's a little, well, pretty similar, but it's not the same as that. It's a different problem from that, but same idea. And so what we're going to do the first time is we're going to kind of go through the process. And so I want us to figure out what is going on in each step. And later we'll talk about why some of this stuff is allowed, but let's get this process down. So U substitution, the goal is going to be to match one of the 11 forms that we've got. And so remember that from last week, and basically from Calc 1, we've got 11 integral forms. We've got the integral of x to the n dx. We've got the integral of 1 over x dx. We've got the integral of e to the x dx. We have 6 trig forms. And then we've got these 2 inverse trig forms. And so, okay, so when we're going to do U substitution, we're going to match one of those 11 forms. And so the 6 trig forms are like way different from any of the other ones, but we're going to match one of the 11 forms. And what's going to happen is instead of x to a power dx, it's going to be u to a power du. And instead of 1 over x dx, it's going to be 1 over u du. Does that make sense to everybody? Okay, and so go ahead.
Are those the only 2 inverse trig functions we're dealing with this year?
Those are the only 2 we're going to deal with. So inverse tangent, the derivative of inverse cotangent is just negative this. So it doesn't let you do any more antiderivatives.
Okay.
And same with inverse cosine. The derivative of inverse cosine is negative this. And then, so the only 2 we're actually ignoring are inverse secant and inverse cosecant. The reason we're ignoring those is because the rules are a little different from one textbook to the next because of domain restrictions with trig.
Okay.
And so anyway, that's technicality, but we're not doing them because of that. And then because the stuff you do for these is basically the same as what you would be doing on those.
Okay. Yeah, I'm certainly not complaining. I was just curious.
No. I'm just letting you know that's why. I figured you guys wouldn't be devastated to not have a 12.
Yeah.
Yeah.
Cool.
Yeah. All right. But we do have these 11. Okay. So anyway, so we're going to try to match these exactly. Now, U sub follows 3 broad steps. Okay. Well, 2 of them are real quick. And the third one's kind of a big step. So the first one is you pick U. Okay. So thinking basically what the problem looks like which of these 11 forms, you think, okay, well, this is basically something to the 9th power. And we'll talk more about that later. But our thought process, so in green, we're thinking we want this to be U to the 9th du, and we'll talk about kind of how to know that more later, but we're going to pick U so that we're going to match that form. So if that's the case, if we want to make it so that it's U to the 9th, what do you think U would equal so that you have U to the 9th over here?
5x to the 4th minus 2.
Perfect. 5x to the 4th minus 2. So we're going to choose for U to equal 5x to the 4th minus 2. All right, and so once we pick that, the second step in U sub is not to choose du. So you don't pick du based on the problem. You find du, and du we're going to define to be the derivative of u times dx. So we're going to define du to mean the derivative of u with respect to x times dx. So back over in the original problem, up here, we're going to say, okay, well then du is 20x to the 3rd dx by definition. So once you pick u, then you figure out what du is. Okay, so those are the first 2 steps. You pick a u, and then you figure out what du is. The third step, which is a lot bigger, the third step is you force the problem, or you make the problem look exactly, scroll up a little bit, exactly like one of the 11 forms. And then you evaluate. Now that's a lot of work, but that's the rest of the problem. And so we're going to make it look exactly like one of the 11 forms and evaluate. And I'll scroll back up in a minute if you didn't get that written down and you want to. But the form we're looking for is u to the 9th du. So we're going to mess with the problem we've got and make it into this. So I'm going to rewrite it, which means I'm going to rewrite it like this. I'm going to put the 5x to the 4th minus 2 to the 9th at the beginning. Why would I do that given that I'm trying to get it to here? What
That's
is
your
the
u to the 9th.
That's the u to the 9th, and I want that at the beginning. Does that make sense to everybody? Okay, so I want the u to the 9th at the beginning. Now, I want du at the end. So I'm not allowed to just like put that in there. I have to use the stuff that was in the original problem. So I've got the 5x to the 4th minus 2 to the 9th at the beginning. I need to do something with the 7, something with the x cubed, and something with the dx. So I'm going to pull the 7 out. I'm going to move the x cubed to the end, and I'm going to leave the dx at the end. So I'm going to rearrange the stuff to make it look like that. Now, let's talk about 2 things on every step of an integral problem. So when we're doing these, and some of them get very, very complicated, you want to be worried about 2 things. So the first thing is, why am I allowed to do what I just did? And the other thing is, why do I want to do what I just did? Okay, so we wanted to do this because we wanted u to the 9th at the beginning. Why would I want to pull the 7 out, do you think?
It's a constant, and it also gets x cubed by itself
Okay, yeah, good. So the 7 is a constant, so I'm allowed to pull it out, and it's really not part of any of this. Like we want the x cubed, but we don't want 7 as part of any of that. So we're just going to pull that out. And then I'm going to move the x cubed to the end because I want it to be part of the du. I don't yet have du, but I'm close to du. Does that make sense to everybody? Okay, so I rearrange it that way because I've got u to the 9th, and now I'm close to du at the end. I'm allowed to do it because you're allowed to pull constant multiples out, and then you're allowed to reverse multiplication. Does that make sense? Everybody clear so far? Okay, now the goal at this stage, so we're making the problem look exactly like one of the rules. The goal is to get it to be u to the 9th du. Well, I have u to the 9th. I don't quite have du. What's different about what I've got from what du is? What's missing?
The 20.
The 20. So instead of x cubed dx, I want 20x cubed dx. Does that make sense? Okay, so I'm going to put that in there. So I'm going to say, okay, equals 7 integral 5x to the 4th minus 2 to the 9th times 20x cubed dx. Okay, so before we go on, why do I want to put a 20 there?
It equals du.
Because that now, does everybody see that? That part, that last part is du. Everybody clear? Okay, so I want that there because that's now du. I've got it, u to the 9th du. Now, what did I technically do to get the 20 there? Did I add 20? Did I subtract 20? To go from x cubed to 20x cubed, how do you do that? Add, subtract, multiply, divide, something else? What did I do? I multiplied by 20. Does that make sense to everybody? Okay, so I chose to multiply by 20. So all right, so 2 things we want to ask. One is, why do I want to do that? So I want to multiply by 20 because I've got du. Okay, so I've got du now. The second question is, why am I allowed to do that? So why are you allowed to multiply the problem by 20?
Isn't the inside and the outside separated?
Yeah, kind of. So it's like 7 times this. Yeah, I think, if I understand what you mean. But why would I be allowed to do this? Why am I allowed to multiply by 20?
Well, technically you're not. You'd have to.
Technically you're not.
You'd have to divide by 20 as well.
Yeah. So, okay. So does everybody get it? Technically you're not. And not just technically, you 100% cannot randomly multiply by 20. Does everybody get that? Okay. So what I've got here is wrong. You're not, like if I give you the problem 5 plus 7, you don't get to say, no, sorry, I want to do 20 times 5 plus 7. Does everybody get that? Okay, so you cannot multiply by 20. Now, whoever that was, I think Jocelyn maybe, I think she said you have to also divide by 20. And that's true. So what I'm going to do is I'm going to multiply by 20, but I'm also going to multiply by 1 over 20. The reason I'm going to do that is because if I multiply by 20 and multiply by 1 over 20, what am I actually multiplying by?
1.
I'm actually multiplying by 1. That is allowed because times 1 doesn't change anything. Does that make sense? Or it doesn't change the value of it. I don't want the 1 over 20 in here. I don't really want it at all, but I have to have it. And I'm allowed to pull it out because it's a constant. Now this step is correct. Does everybody follow what happened from here to here and why we would want to do what we just did? Please ask if anything's confusing. Any questions?
So you were mentioning earlier about this method is going to be easier later down the road.
Yeah, and I think it's harder right now if you've learned a different way.
Yeah. The only difference in the way that I do it is
you divide by 20.
Yeah, modify that equation.
Yeah, I would avoid that for later.
Okay.
But you don't have to. And that's what I was saying up front. Just because I like this better and I think it's better doesn't mean you have to agree with me to make me happy. Does that make sense? So I will not be mad if you do it. But after teaching Calc 2 a lot, I think that if you can get good at this way of doing U-sub, you will be better later at harder problems that you haven't yet done. Does that make sense?
Yeah.
So I would try it. If it's going to screw you up, then no, that's fair. Does that everybody get what I'm saying?
Yeah, give it a shot.
Completely fine. So some people have never learned U-sub, and so then I would just do it this way. Some people have learned U-sub this way, and great. And some people have learned it a different way, and that's okay too, but I think that'll be harder for you later, just so everybody understands what we're talking about. Okay, questions on what's happening here? We're good?
In the center top line,
Yes, right here.
that has, yes. On the
Okay.
left side of that equal sign, is that a DX or a DU?
That is a DX.
Okay.
Sorry.
Just
my
wanted to make sure. So it says
you were good.
DX equals 7 integral
Well, it's
5x
saying this
to the
whole
fourth.
integral is equal to 7 times that.
Okay. Okay. That makes a lot more sense. Thank you.
This whole integral is the original problem. And on the next
Okay.
one, I'll make that a different color so it's clear. Sorry about that, Kyle.
No, that's fine. I just
Okay.
had the wrong line. Thank you very much.
You were good. All right. Other questions so far? Okay. All right. So then the idea is now this part is u and this part is du. So I'm going to rewrite the problem using that. So I'm going to say, okay, well, 7 times 1 over 20 is 7 over 20. And then I've got u to the 9th du. Is everybody clear why, based on this, I can rewrite what we've now got this way? Any questions to there? And if you've never seen this before, I understand it's very weird. And if you've done it a different way, this is pretty weird still. So make sure we understand, because we're going to use this a ton this semester. Everybody good to hear? Okay. Now I want you to ignore everything on the screen except for this very last line. Okay? If that was on the homework over the weekend, that would have been one of your easier problems, right? How do you do the integral of u to the 9th du? What do you do?
U to the 10th over 10.
Perfect. 1/10 u to the 10th or u to the 10th over 10, same thing. And so the integral of that becomes this. We're allowed to use that rule because the variable matches. If it was u to the 9th dx, we could not do that. Because it's u to the 9th du, we can. And so we apply the rule like normal, ignoring everything up here at that stage. Does that make sense? Everybody clear? Now, this could have been any of them. It could have been e to the u du, or it could have been sine u du. And as long as it's one of these 11 forms and it's u here and u here, then we can apply the rule like normal. Now, there are 2 bad things about the answer. One bad thing is we should multiply these fractions together and make it 7 over 200. The other bad thing is that I gave us this problem, and now we're giving an answer that says u to the 10th, and we made up u. Does that make sense? That was not part of the problem at all. We made that up. So you cannot leave the answer in terms of u. But the big difference between the line before this and this answer is we have now done an antiderivative. We've actually used the integral rule. And so what we're going to do is we're going to first make that 7 over 200, because you should simplify. And then we're going to replace u with 5x to the 4th minus 2. And that is a 10, not a 16. And so we should have 7 over 200 times 5x to the 4th minus 2 to the 10th plus c. And that's actually the answer on this problem. All right. Lots of weird stuff, especially if we've never seen it before. But even if we have seen it before, it's a little weird. So questions on any of what's going on. All the color stuff, so the red, the blue, the green, that's all stuff we're thinking. It's not part of the problem. The stuff I have in black print, that is actually the sequence of steps that you should show as part of this problem. Okay? Any questions at all? Please ask. Somebody's in the chat. What do we have in chat? Let's see.
Are we taking the antiderivative of what is in the center then, or just leaving it as that?
We're taking the antiderivative of all of it, technically. So if I were to take the derivative of this answer, I would get 7x cubed times 5x minus, or 5x to the 4th minus 2 to the 9th. Does that make sense? I'm not sure who asked that, but
Yes.
you follow what I'm saying, Isaac, I think? Yeah?
Yep.
Okay. So similar to like what's up here, like if I took this, see how I took the derivative of this and got this? So same deal. If I took the derivative of our answer, I would get exactly this if I simplified. Okay, and now let's see. So where did we get the 1 over 20? Okay, so yeah, Andy is answering Sam correctly in the chat that when we multiply here, so Sam, we understand that we needed the 20 because I wanted du here, and du has a 20 there, right? And so in order to get the 20, I also multiply by 1 over 20 because what they're saying in the chat is right, that if I multiply by 20 and by 1 over 20, I then multiply by 1, and I'm not messing with the problem at all, other than to change the way it looks, but the problem is still the same. If I were to just put a 20 in there, I've changed what the problem actually says. Okay? And the other people, okay, awesome. Does that make sense, Sam? We're good? Okay, awesome. All right, so what I'm gonna do is I'm gonna put a problem on the screen. I don't know what you're watching this on, but if you didn't copy this one down, maybe screenshot it real quick, if you can do that. And I'm gonna put a problem on the screen that is almost exactly the same. And I'm gonna give you like 2 minutes. And what I want you to do is try to work it following these steps exactly. Because right now, what I wanna get is this process down. I want us to be able to do this. Then we'll talk more about how do you pick this stuff? Like, why is u this? Why is du this? What do you do if it's different? Like, what if that x cubed isn't there? We'll talk about lots of different stuff related to this, but right now I just want to get the mechanics of this down. Let's be able to do this. So the next problem, do almost exactly the same way. And take a minute and please try it. So if I have 5x to the 7th times to this, let's say 19th. Okay, so that is the original problem. And I'm going to put a solution up in a different color here in a couple minutes. But let me give you, it's 12:57. I'm going to give you till 1 o'clock. I want you guys to try this. And if you do have a question for me, just send it in the chat or unmute yourself and I'll try to answer that. But everybody else keep working on this. See if you can get it. We got 2.5 minutes. Okay, so I wrote a solution up that I think is right. If I have done something wrong, definitely let me know. But check what you've got because I think I'm good. And if you have something different, let's figure out why. Just unmute yourself, send something in the chat. I can see that today. Let's see if this is what we're getting. Are most of us getting that?
That's what I got.
Awesome.
I got that too.
Okay, sweet. Yeah, pretty sure it's right. And so just double check that your steps are looking pretty much like this. If you've learned U sub where you like divide over here, that's okay. You should get the same answer. But again, I would try this way because I think it's going to be easier for you later. Right now, it's probably actually a little bit harder, but not much. Just making sense? Any questions at all?
I had a question.
Sure.
Does it still work out if on the outside, like in this problem, we have 5x to the 7th, and then on the inside, we have 2x to the 8th? Does it still work out if you have an exponent on the outside that's not one less than the one on the inside for dx?
Not this easily, and maybe
Okay.
not at all. And so if this was like 5x to the 6th here, then the option would be to multiply this out 19 times and distribute that. And I'm actually not kidding. Do you see what I'm
Okay.
saying?
Yeah.
And so this is, and that's kind of what I mean by right now, we're going to try to get this process down. And what you're asking is exactly the next stuff we should be worried about. That like, what if this doesn't match this? And so sometimes we can get that to work out in a better way. My guess is that in almost every case here, you would have to multiply that out, but we would have to look at those individual problems. Does that make
Okay.
sense?
Yeah.
Okay. Really good question. That's what we should be thinking about once we get this down. Okay, other questions?
Are you going to take points off on like an exam if we don't completely simplify our final answer?
You should simplify. So like if you have -5 over 320, I probably would not take off much for that. But aside from that, is that what you had, Olivia? That's my guess. Yeah, all right. So the good way to know that that was 64 is to cancel here. That's what I did. I did not actually divide 5 into 320. But that is not something you should be that concerned about. Does that make sense? Like if it's an 8-point problem, that's at worst 1 point off. You get what I mean? Okay.
Yeah,
Okay.
Thank you.
Yeah. I mean, try to simplify, but that should not be the focus. Okay. All right. Other questions? All right. Most of us are getting this. That's good. Okay. All right. So we're going to do some more. And like I said, we want to be thinking about, okay, how do we kind of know what's going on and what happens if this doesn't match? And there aren't great answers to those questions. So we're going to get good at this, but we're going to see that if there's slight changes, we can't get this to work every time. So like the X to the 7th had to be there for this to work. The 16 did not. We're able to get constants usually, but we're not able to get letters that we don't want, or at least that's a lot harder. And we'll look at that more later. But let's look at another problem where we do something similar to this. And let's say I've got, okay, we'll do 4e to the 3x times 2e to the 3x plus 1 to the, say, 7th power dx. And so let's start this together, and then I'm probably going to have you guys finish it without me, and we'll get into how this works. But when you're looking at the problem to start out, the first thing really should be what form are we going to try to match? So if we're going to use U sub, like those 11 forms we've got, and so we could try to match x to the n dx, or we might try to match that, and then there's 9 other ones that I think wouldn't apply probably to this one. But does everybody see that, like, if we're going to try to match this where it's e to the u du, there's really too much going on here for that to work well? Does everybody see what I mean? And so we'll look at one like this in a minute, but our thought on this one, yeah, and so the e to the x, the problem is that there's like too much of that. And so what's going to end up working here is that we're going to try to match u to the 7 du, and let's see why that ends up working. So if I'm going to try to match that, what would u have to equal if that's the case? Somebody tell me. If we're going to match u to the 7
2e to the 3x plus 1.
Perfect. So u would equal 2e to the 3x plus 1. And then if that's the case, du is the derivative of that. And now be careful, but the derivative of that is 2e to the 3x, but then times 3 because of the chain rule, which means it's really 6e to the 3x dx. Now, before working the rest of the problem, we know this is going to work because we can use this e to the 3x for the du. Does that make sense to everybody? That's clear? Okay, so I'm going to work it. If you think you're good, work it on your own, but I'm going to kind of talk through and work it on the screen over here. So I'm going to pull the 4 out. I'm going to put the 2e to the 3x plus 1 to the 7th at the beginning. And I'm going to put e to the 3x next to the dx because I'm going to use that one for du. Questions on that step? Okay, so then I need a 6 there, which means I'm going to multiply inside by 6. And if I multiply inside by 6, I need to multiply outside by 1 over 6. And now I've got it to the form that I want. Everybody clear? Good. Questions so far? Okay, and we need to be real careful that we're actually getting du from what's within the problem. So like had that e to the 3x not been there, we would not have been able to do this problem in this way, okay? So you have to be real careful that you're getting this from what's in there. The 6 we put in ourselves because of the 1, 6, but the e to the 3x came from within that problem. So now we do the antiderivative. We get 2/3 times 1/8 u to the 8th plus c. The 2 cancels with the 8. And so we get 1 over 12 times 2e to the 3x plus 1 to the 8th plus c. And that's the answer. Any questions on that problem? Everybody's comfortable with that? Those are good. Okay. All right, we're going to move on to some more. Okay. All right, I'm going to move on. And then remember that even though you guys are attending the live session, you can always watch this later. I'll post this tonight as soon as it's available, basically. So it should be up, and you can always rewatch parts of this if you want to. Okay, so we're going to put now 5x e to the 3x squared dx. Okay, so if I have that problem, this problem, the main thing going on is that we've got e to this power. And so our goal ends up being that we want to match the form e to the u du this time, because this time it is the main thing, and it's not entirely clear that that's going to work, but it is once we start to set up the u and the du. And so if we're going to match e to the u du, what do you think u would need to equal in this problem?
3x squared.
3x squared, good. So u would equal 3x squared. And then if that's the case, du is then 6x dx. Why now is it clear that this will work? What about the problem indicates that this is going to work?
There's an x dx.
Yes, this x that we need for the x dx, that is there. If the x were not there, or if this was x squared or x cubed, this would be harder, or at least it wouldn't work directly this way. Does that make sense to everybody? Okay, but because this variable part that we want is there, it's going to work where it's pretty straightforward. So we don't need the 5, so we pull that out. We need the x next to the dx. Any questions to that point? Okay, now what do I need that's not in the problem?
6x.
6x, perfect. So I've got x, I need 6x. So I multiply inside by 6 and outside by 1 over 6. And so I've got 6x dx. That part matches this, so we can replace that with du. Is everybody getting that? And please ask if not. Some of us, this is the very first time we've ever seen this. Some of us have done this before. Either way, it's fine. We're good? Okay, so the 6x dx, we replace that with du. The 3x squared gets replaced with u. So we've got 5/6 integral e to the u du. And now we ignore everything above that. Questions? Okay, so now the integral of e to the u du, what is that?
Five six EU times U.
Perfect. 5/6 e to the u plus c. So 5/6 e to the u plus c, and we're not quite done, but this step is like the stuff from last week. So like you're just looking at it as a brand new problem. It's important that this u here must match the du here. If this is e to the u and this is dx, it does not work. We clear? And now the only other thing is I need to replace u with the original substitution. So it's 5/6 e to the 3x squared plus c, and that's the answer. Questions? Everybody good? Okay. All right, we're going to try another one. Let's do that. Okay, so if we're looking at this problem, as far as the 11 forms that we've got, there are really 2, maybe more, but there's 2 that look a lot like this one. And so one of them is that it could be 1 over u du. And another one is 1 over 1 plus u squared du. And so both of those resemble this. Does everybody see why? Do we get that? Okay, and so we'll talk a lot more about the difference between these two tomorrow. So you'll see when we're doing these problems tomorrow, they step up in difficulty quite a bit pretty quickly. And it's because of things like this, where these forms look almost identical. But if we're gonna use the first form, okay, and we don't know for sure that that's gonna work until we figure this out, but if we're gonna use the first form, what would u equal if we're gonna use that 1 over u du over here?
Five x squared plus 7.
Yeah, so if it's gonna be that first form, u needs to be the entire bottom. Does everybody get that?
So we can't have it be 3/5 in the front. You can't
If
make
you
ux
did,
plus
you
7.
can. If you did that, then it would be x over x squared plus 7/5. Because the five, and actually there's nothing wrong with that. It just turns out on this problem, we don't need to do that.
Okay.
Does that make sense?
Yeah.
Okay, but in a lot of problems, especially ones that are gonna match this, it's not that we're gonna take that 5 out, we're actually gonna take the 7 out so that that becomes a 1. And so we'll see that tomorrow more, but that's actually really good to think about. It's just not necessary on this problem because of what happens next.
Gotcha.
Make sense? Okay.
Mm-hmm.
All right, does everybody get what he's asking? That's worth thinking through. Okay, so we don't need to do this, although we could, and it wouldn't be wrong. But why? So what I'm saying is now, based on what happens next, this is going to work because du is 10x dx. So how do we know now that this approach does work? What about this problem and this du means that we can get 1 over u du? We have the x that we need. Does that make sense? Okay, so what I'm going to do is I'm going to do this all in one step, but then I'm going to talk about the algebra for a second. I'm going to pull the 3 out, and then I'm going to put the x next to the dx. Now, that is allowed, and the reason that's allowed is because when you multiply fractions, you multiply straight across. So this is the same thing as 1 over 5x squared plus 7 times 3x over 1, which means it's the same thing as 1 over 5x squared plus 7 times 3x, and then I can just pull the 3 out. Does everybody understand that algebra? We good? Okay, and it's because when you multiply fractions, you just go straight across. If you add or subtract fractions, you need a common denominator. Not true for multiplication. So this is the algebra behind why this is allowed. Any questions on what I'm doing here? Okay, so now what else do I need that's not there?
10.
I need a 10. So I'm going to multiply inside by 10 and outside by 1 over 10. So then I get 3 over 10 integral 1 over u du. Questions to there? Good. Okay. And now what is the antiderivative of 1 over u du?
ln of u.
ln of absolute value of u. Perfect. So 3/10 natural log absolute value of u plus c, and then 3/10 natural log, whoops, of 5x squared plus 7 plus c. Okay, and so like I said, the stuff I'm writing in blue, those are the steps you should have as part of your problem. The stuff in red is stuff we might be thinking through or might do on the side, but the stuff in blue should be written. Questions?
So then does the 5x squared plus 7 not have to be absolute value?
Really good question. And let me answer that one last. Okay, so the question is, why did I drop absolute value pretty much? And so that's okay here, and it's not always okay. So let's see if there's any other questions, and then I'll talk about why it's okay here. Okay. Any other questions on this process? We getting this? Okay. We good? Okay. Now, in this case, the reason it's okay to drop absolute value is because if you take, when does absolute value not change a number?
When it's positive.
When it's positive or when it's 0. How do I know in this case that u is positive?
Because it's squared.
Because it's 5x squared plus 7. So 5x squared is at least 0, and then I add 7. And so I know it's positive, which means I'm allowed to drop the absolute value. If you did not drop the absolute value, that would be okay. You can have it still. Does that make sense? And in this case, it's okay if you drop it. If it had been 5x squared minus 7, you could not drop the absolute value. Does that make sense? Does that answer your question? Everybody good? Okay. So if you're worried about that, it's safer to just keep it. I usually will drop it if I know that whatever's in there is positive. Okay? All right, I want to look at a couple more and then we're going to be good. But is everybody good so far? Any questions? Okay. All right, so then okay, so what if I just have 5x minus 1 to the 10th dx? So could we use u sub on 1 this straightforward? If we were to use it, what would we try to match, do you think? What rule? What would be the goal?
One over something.
Probably not that hard. You're good, but like what general rule, if we were to replace something with u here, what, like, does it look like the power rule? Does it look like 1 over u? Does it look like e to the u, trig, inverse trig?
X to the n dx.
Yeah, so we can make this be u to the 10 du because it looks like x to the n dx. Does that make sense to everyone? Now, maybe that doesn't work, but that's at least what this generally looks like. And so if it looks like that and we're going to try to do that, what would u equal?
5x minus 1.
5x minus 1. And now that's weird because that's really simple, but du then is what?
5.
5 dx, perfect. And so because there's no variable with this, it's good that there's no variable out here. And so I just need to change dx to 5 dx. Well, to change dx to 5 dx, I still multiply by 5. And then I multiply outside by 1/5. There's just nothing to move around at first. So it's technically easier, but it's weirder. Does that make sense to everybody? Questions? Okay, so now this is 1/5 integral u to the 10 du. That's then 1/5 times u 1 over 11 u to the 11 plus c. That's then 1 over 55 times 5x minus 1 to the 11 plus c. And that's the answer. Does that make sense to everyone? Any questions? Okay. All right, so I want to talk about this one for a second. So now, what do we almost always do? We don't always, but what do a lot of times with square roots when we're dealing with derivatives and integrals?
Change it to power.
Yeah, change it to a power. So we could change this to x times 16x squared plus 25 to the 1/2. Does that make sense to everyone? How would we then approach this problem? So u would equal what, do you think?
Probably that inside.
Yeah, the inside. So we're going to let u equal 16x squared plus 25. Du then is 32x dx. So then there's no constant to pull out, but we want to move the x to the end. And now we need a 32. So we multiply inside by 32 and outside by 1/32. And now that's u to the 1/2 du, and we're going to go from there, and I'm going a little quicker. Questions to there? All right, so u to the 1/2, the antiderivative of that when it's du is 1/3/2 u to the 3/2 plus c. That's 1/32 times 2/3 times 16x squared plus 25 to the 3/2, whoops, 3/2 plus c. That's then 16 and 1, so 1/48 times 16x squared plus 25 to the 3/2 plus c. Does that make sense? Questions? Okay. If I gave you this problem instead, let's make that cube root. What do you think you would do differently?
You just make it x to the negative 1/2 instead of, or x to the negative 2/3.
Negative 1/3,
Or
because I
1/3.
change it real fast. But yeah, so it would be x times 16x squared plus 25 to the negative 1/3, and then we would do it. Does that make sense? And then what if I had, say, 5x to the 4th over 6x to the 5th minus 1 to the 8th? What do you guys think we might do to that?
Yeah. This is 6x to the 5th minus 1 to the negative 8.
Bring it up and make it negative 8. Yeah. So like the one up here, whoops, the one, man, way up here, where it's the bottoms to the first, we probably don't want to bring it up because it'd be to the negative 1. But then when it's down here, we can bring it up and make it to the negative 8. And now this one will work out. Some won't, but this one will. And now I want to talk about one other thing that can happen, but now it should be pretty straightforward to finish that. Does that make sense? Okay. All right, so I'd like you guys to try that one and then check it with me in just a second, and then we'll talk about homework and then we'll be done. All right. So the answer is on the screen. I kind of skipped one step and combined them into that first step. I pulled the 5 out and moved the cosine 2x to the end, and then went ahead and multiplied by 6 and 1 over 6. How many of us are getting that? You guys getting that?
Yep.
Okay, awesome. Okay, so I want to talk for a minute about homework. So U substitution, we're going to be working on most of this week. It's going to get harder, and it's going to get harder tomorrow a good bit. And so what I want you to worry about tonight is, first of all, getting this process down. Okay, so being able to do these steps once you know it's U sub. On the WebAssign homework, you'll see it's U sub 1 on WebAssign. There are a couple mixed in that are not U sub. And I want you to think about, okay, when you find one that ends up not being U sub, what about it means that U sub doesn't work? Does that make sense? Okay, so be thinking about, okay, how do you know that when it works and when it doesn't? I'm going to start putting deadlines as 11:59 p.m. to avoid confusion and not try to do it before class. But if you're attending the live lecture tomorrow, I would really recommend that you do this before the live lecture, because you want to have this down, or at least do a bunch of it before. The other thing I want to talk about real quick is in the shared drive, you should now see, can you guys see my shared drive now? The list of folders, okay. So you should see under Unit 1, you should see, okay, review, that's worksheets from last week, and they're in here as PDFs. And then U substitution I just added this morning. U sub 1 is a handout I would normally kind of assign you, but instead we're doing the WebAssign. Those problems would be good to look through. And then solutions has actually like worked out solutions. So not just the answer, it has the steps there. These are too advanced based on what we've done today. We'll get to these other ones through the week, but U sub 1 and the solutions would be worth looking at as well. I'm not going to make you do them. You have to do the ones on WebAssign. WebAssign's pretty close to this, but it would be worth looking at that and using the solutions. All right, so if you have questions, go ahead and stick around. I'll stay on with anybody who has a question. I'm free for a little while. If not, I will hopefully see you tomorrow. But try to do the homework before you come or before you watch the video if you're going to watch the video tomorrow night. All right, thanks, you guys. Thanks for coming.